Hey everyone. Rate of change is all around you in your daily life. Morning, afternoon, midnight, you name it. Rate of change is represented by the slope of a line. It is often used when speaking about momentum, and it can generally be expressed as a ratio between a change in one variable relative to a corresponding change in another. Our objective here is to see the rate of change in the average NBA players in the past from years 1980 to 1990 to 2000 and 2010 in point guard position. What is the average height of an NBA basketball player from the years 1980 to 2010? We'll be seeing the difference in heights over the years to find the rate of change in heights. See if it has gone up or down in the years. Hey everyone, and here I'm going to show you how to do rate of change. This is just a sample problem. You don't have to do any work here. You just have to see how to solve rate of change equations. So here it says find the slope of the line given 2 points. So on a line, there are these on a line on a graph. There are these 2 points. And to set this up, it's supposed to be y2 minus y1 over x2 minus x1. And so here on both points, your first point is x1, y1, and then x2, y2. So you have to use those to set it up like that, like it's shown here, which is -2 plus 3, which is both y's on top, y2 minus y2, y1, and then at the bottom it's x2, x1, which is 7 minus -3, which is 7 plus 3. And doing the math, your answer would be 1/10.
Okay, yeah, so today we're gonna be showing you the rate of change of the height of basketball players over the years in inches from the years 1980 through 2010. And the positions are point guard. And so for our year 1980, you can see that we have 73.9 inches. And then in the year 1990, it slowly decreased by 0.3 inch of an inch, and then it decreased again in the year 2000 to 7.4, and then 73.4, and then it bumped up into 2010 to 73.8. So as we can see, 1980 was our highest year, and then so this would be our negative, and then we would have a positive, and then it would just stay like that at 2010. Yeah, it's pretty good and fresh. I mean, I don't know what else you want me to say.
Example problem we're going to be doing to show you how these rate of change and how to find the slope of each variable. And one of the slopes we're going to be showing you is between 1980 and 1990.
Mm-hmm.
So we're going to so our sample is going to be y2 minus y1 and x2 minus x1. Y is always going to be on top and x is always going to be on bottom. So and then our example problem is going to be this one, 73.9 minus 73.6, and then 1980 minus 1990. Now, I'm going to let you guys have a hot second to do that, or pause the video right now to figure out your problems. I don't know if I'm on the right thing, but sorry.
Okay.
Okay.
Welcome back.
And if you guys got the same answer as 0.3/10, it's positive. So yeah.
You're correct.
And you're correct. Good job. If you weren't, that's too bad. And some of the slopes that weren't in this little data plot were 0, where it just goes in like a straight line here. Let me get a pen for you guys. Where it goes in a straight line. That's not very straight. But like that, where it doesn't go like up or down. And then another one is undefined, where undefined is where your plot line kind of just goes haywire and just dips on you, and you're like, well, okay. So, yeah, those are like 4 plot points or like slope, where, let me recap, negative when it goes down, positive when it goes up, 0 when it's straight, and undefined when it just dips. So today we're going to be doing like a problem that went with the first part of this video that like you're kind of watching here. And we're going to be using the years, if you didn't already remember, the years 2000 and 2010. And these are different from the first problem because, I guess that one was kind of like a practice. Now it's kind of like this actual one, or I'm going to like show you through it. So you're always going to have like y2 minus y1 over x2 minus x1. And for our y2, we're going to have 73.4. And then for our y1, we're going to have 73.8. And then we're going to put that all over, and then for our x2, we're going to have 2000, or yeah, whatever, minus 2010. And then I'm going to leave, and then you're going to basically just subtract all of these, and that's basically going to give you guys a slope. So I'm going to let you guys do that. And yeah, so have a nice day. Calculator.
Don't talk about yourself like that.
So 73, here, let me get 0.4 minus 73.8. That's going to equal negative 0.4. So we're already in points on our graph, so it's not going to like look like this, but that's okay. And then next we're going to be doing 2000. Let me focus. Next we're going to be doing 2000, so 2000 minus 2010. And then we're going to equal that. And that's going to equal, kids, negative 10. Let me put an equal sign. And since they're both negatives, you can turn this, or like simplify it, into a positive. So that's going to equal 0.4 over 10. And I don't know if this is like going to be t or like true or not, but that is going to equal, if we simplify it down, to 5 over 0.2. I think. But so if you guys like this video, I hope you guys enjoyed it. So
All of this proves right back to the main thing, which is that rate of change can be all around us. It can be found in sports, clubs, activities, movies, games, you name it. I hope you find all this very important, useful, and entertaining. Thank you for watching.